In the following animation, we are going to explore the components and the sequences of operation for Heatcraft's Mojave reverse cycle defrost system. The system components of the Mojave hot gas defrost system, beyond those of a normal refrigeration system, are the bypass valve, the suction solenoid valve, the three-way valve, the defrost solenoid valve, and the electronic pressure regulator and its associated filter. In the cooling cycle or standard cycle, the solenoid valve opens first and allows refrigerant flow through the thermal expansion valve and the evaporator. The refrigerant flow continues on through the suction filter and suction accumulator to the compressor. The refrigerant is then compressed to a discharge gas that flows through the condenser. The gas condenses and deposits liquid into the receiver. Then the liquid goes through a subcooling loop and through a filter dryer before returning back to the solenoid valve. The refrigerant will continue this cycle until desired temperature is reached or until the start of a defrost cycle. During the pump down cycle, the liquid solenoid valve is closed and the compressor will continue to run until it pumps down all the refrigerant from the low side to the receiver, the high side of the system. The low pressure switch will turn the compressor off because the refrigerant has been transferred, and then the system will shut down. In the defrost cycle, first there is a pre-defrost to equalize the refrigerant pressure between the condensing unit and the evaporator. The suction solenoid valve closes and the bypass valve is opened. High pressure liquid from the receiver goes back through the subcooling loop. Now instead of going directly into the evaporator, the high pressure liquid goes through the side inlet of the evaporator and fills the evaporator with high pressure refrigerant in preparation for defrost cycle. In the defrost mode, the bypass valve closes. The defrost solenoid valve opens, the three-way valve is activated, the pressure regulator partially opens and allows refrigerant to flow through the condenser, absorbing heat from the outside, boils off the refrigerant, goes through suction accumulator into the compressor, and the three-way valve directs the discharge gas into the side inlet of the evaporator. The evaporator becomes the condenser and the refrigerant changes from a vapor back to a liquid, and then the liquid flows back into the receiver and will keep the flow going back through the pressure regulator. The pressure regulator will modulate to keep the right pressures on the compressor. It's acting as an expansion valve which regulates the superheat. It will stay that way until the coil warms up enough until there is no more frost on the evaporator coil, and will then terminate the defrost cycle. The post-defrost has two purposes. The first is the transfer of high pressure refrigerant in the evaporator back to the receiver by way of the pressure regulator. The pressure regulator is open 100% during this step. The second purpose is to provide drain down time for the warm evaporators. This allows the water that was melted off the coil to drain out of the evaporator drain pan. After the drain down time, the three-way valve closes, the suction solenoid will open, and then the compressor will turn on. When the pressure falls below 20 psi, the liquid line solenoid is activated and the system will return to the cooling cycle.